It's October 3rd, 2025, and high above the rusty dunes of Mars, a fleet of silent sentinel spacecraft from Earth, orbiting like watchful guardians, turn their eyes toward a flickering streak in the void. The interstellar comet, known as 3I/Atlas, is hurtling closer, just 30 million kilometers away, a cosmic wanderer brushing past the red planet, in what feels like a whispered secret from the stars. Cameras on NASA's Mars Reconnaissance Orbiter and Europe's ExoMars Trace Gas Orbiter hum to life, capturing every glint of its dusty tail, every puff of gas escaping its icy core. What if this isn't just a rock? What if it's carrying echoes of ancient worlds? Or something more deliberate, like a message etched in frozen carbon dioxide? The tension builds as data streams back to Earth, revealing hints of a composition that mirrors Mars itself, rich in CO2, laced with cyanide and nickel, but curiously lacking iron. Could this be a fragment from a long-lost catastrophe, or a probe testing our skies? As the comet streaks by, scientists hold their breath. This close encounter isn't a collision course, thank goodness, but it's intimate enough to let us peer into its heart. The orbiter's instruments detect water vapor and organic whispers, teasing possibilities that make your mind race. Is it alive with microbial remnants from another star system? Or engineered, as some daring thinkers like Avi Loeb suggest, a relic of extraterrestrial technology disguised in a cometary cloak? The flyby lasts mere hours, but in that moment, humanity glimpses the infinite, a reminder that our solar system isn't a fortress, it's a crossroads for travelers from afar. Now, let's pull back from that dramatic rendezvous and trace how we got here. It all started on July 1st, 2025, in the crisp night air of Rio Hurtado, Chile. Astronomers at the Atlas telescope, a NASA-funded eye on the sky, spotted a tiny speck of light darting against the starry backdrop. At first, it seemed like just another asteroid, but calculations quickly revealed its speed, a blistering 135,000 miles per hour, far too fast for anything bound to our Sunday. This was no local drifter. It was an interstellar intruder, the third ever confirmed, earning the name 3I/Atlas. Excitement rippled through observatories worldwide as pre-discovery images surfaced from archives, pushing its detection back to June 14th. Suddenly, we had a visitor from the depths of the Milky Way, billions of years old, carrying clues about distant stellar nurseries. Compare this to its predecessors, and the mystery deepens. The first interstellar object, 1I/Oumuamua, discovered back in 2017, was a cigar-shaped enigma that tumbled through our system without a tail, accelerating oddly as if propelled by unseen forces. Avi Loeb, that Harvard astrophysicist with a knack for bold ideas, famously proposed it might be an alien sail catching sunlight to zip away. Then came 2I/Borisov in 2019, more comet-like with a visible coma and tail, but still an outsider. 3I/Atlas fits somewhere in between, active with a diffuse cloud of gas and dust, yet its reddish hue and chemical makeup raise eyebrows. Hubble snapped images on July 21st, showing a teardrop-shaped cocoon of dust around its nucleus, while Spherex data from August revealed CO2, fog and water ice, plus those intriguing traces of cyanide and nickel. No iron, though, which is odd for a typical comet. Estimates peg its size between 1 and 10 kilometers, but its brightness fluctuates with activity, making it hard to pin down. What if that variability isn't just outgassing? What if it's adjusting course, subtly, like a craft scanning for something? As Atlas barrels inward, its path paints a poetic arc. Originating from the direction of Sagittarius, It crossed Jupiter's orbit by early July, now racing toward its closest solar kiss on October 29th at 1.36 astronomical units, about 126 million miles from the Sun, snug inside Mars's orbital lane. After that, it'll sling outward, passing Venus in November and grazing Jupiter's influence in March 2026 before vanishing into the galactic night. No major planetary close calls, except that Mars flyby, which feels almost too perfect. At 29 to 30 million kilometers, it's safe, but tantalizingly near closer to the red planet than to Earth. At 270 million kilometers, scientists see gold here. Mars orbiters like the high-resolution imaging science experiment on MRO could capture details finer than Hubble's, revealing the comet's nucleus shape or even erupting jets. Europe's Mars Express might sniff out molecular signatures with its spectrometers, hunting for organics that could hint at life's building blocks delivered from afar. But let's weave in the what-ifs that keep us up at night. Studies suggest Atlas is ancient, between 3 and 14 billion years old, born in the thick disk of our galaxy, where stars are metal poor and orbits tilted. It might have been ejected from a distant system eons ago, wandering alone until gravity tugged it our way. Yet, its velocity 58 kilometers per second excess implies a targeted plunge, not a random drift. Avi Loeb's latest musings in a September 2025 paper speculate, what if it's not natural? Its CO2 dominance echoes Mars's or Venus's atmosphere, not a primordial nebula. Could it be debris from an ancient planetary cataclysm, or a survivor craft looping back after interstellar exile? Online buzz on platforms like X amplifies this posts about abrupt direction changes, plasma shields, even jokes about aliens eyeing Mars for a Tesla deal. One thread calculates a hypothetical velocity tweak near Mars could send it Earthward by December 28th, sparking doomsday whispers. Mainstream science dismisses these as outgassing illusions, but the seed of doubt plants a thrilling uncertainty. This comet's story isn't just data points, it's a bridge to bigger questions. Why does its composition lack the hydrogen richness of solar system comets? Perhaps it formed around an older star, stripped bare by cosmic winds. Or maybe it's a fragment of a shattered world, carrying isotopic scars like Mars's own xenon anomalies, hints of past disasters. As it nears, brightness could spike if water escapes, turning it into a naked-eye wonder from Earth by December. But from Mars's vantage, the view is unparalleled, a chance to decode its secrets up close. NASA's Perseverance rover, roving Jezero crater, might even catch a glimpse if the coma expands, linking this interstellar guest to the rover's hunt for ancient Martian life. Speaking of sharing these wonders, if you're curled up listening to this under the stars or in a cozy bed, why not hit that like button to spread the cosmic curiosity? And if you subscribe, you'll catch every episode where we dive deeper into the universe's mysteries. Drop a comment below, tell us where you're tuning in from and what time it is there. Is it midnight in New York or dawn in Tokyo? Your stories make this journey feel connected, like we're all stargazing together. Now, back to our visitor. As we ponder Atlas's origins, consider the galactic context. Our Milky Way teems with such nomads. Estimates say one interstellar object passes through our system yearly, but spotting them is rare. Atlas's hyperbolic orbit, with an eccentricity over 6, screams outsider, unbound by the sun's grasp. Its inclination, nearly 175 degrees, means it's looping retrograde against the planetary flow, adding to the intrigue. What propelled it here? A stellar close encounter billions of years back, or something engineered for reconnaissance? Loeb's Bayesian analysis leans toward the extraordinary. If anomalies persist, no iron vapor, yet nickel present, suggesting processed materials. Imagine a probe sampling atmospheres, now drawn to Mars's CO2 veil like a homing beacon. The flyby's scientific haul could rewrite textbooks. If organics abound, it bolsters panspermia, the idea life seeds hop between worlds. Water ice detected hints at delivery mechanisms for Earth's oceans, echoing recent Devil Comet findings. But the real thrill, that subtle anti-tail spotted by Hubble, a forward-pointing dust stream defying norms, natural or thrust exhaust? As Atlas glows green during eclipses, wait. Reports vary. Some say reddish dust dominates, but lunar alignments reveal emerald hues from cyanide gas. It's these layers that captivate. A rock-solid comet with whispers of the artificial. Wrapping this opener, remember, October 3rd isn't just a date, it's a cosmic blind date. Mars meeting a stranger from the stars. Will it reveal peaceful origins or stir ancient echoes? As data pours in, we'll know more. But for now, let the suspense linger. This is just the beginning of our tale, where science meets speculation and the universe unfolds one mystery at a time. Stay tuned. The stars have more to say. Picture this cosmic oddball tumbling through the void like a discarded cigar from some galactic party. 1I/Oumuamua, the first interstellar visitor we ever caught, sneaking into our solar neighborhood back in 2017. Discovered by astronomers at the Pan-STARRS telescope in Hawaii, this reddish, elongated rock, about 800 meters long and just 40 meters wide, didn't behave like anything we'd seen before. It zipped in from the direction of the constellation Lyra, slinging past the sun at a hyperbolic speed that screamed, "I'm not from around here." No coma, no tail, just a silent, spinning enigma that accelerated away as if eager to escape our prying eyes. What made hearts race was that unexpected boost. It wasn't gravity alone. Sunlight seemed to push it, like a solar sail unfurling in the vacuum. Avi Loeb, that sharp-minded Harvard professor, couldn't resist stirring the pot. What if this wasn't a natural asteroid? What if it was an alien probe? A light sail crafted by some distant civilization to scout the stars? The idea ignited debates that still flicker today, blending hard data with the thrill of the unknown. Oumuamua's faint red glow hinted at organic tholins, cosmic ices baked by radiation over eons. But its shape? Too flat, too elongated for a typical space rock. As it faded into the distance, now beyond Neptune's orbit, it left us wondering, was it a fragment of a shattered exoplanet, or something engineered to whisper secrets across the light years? Fast forward to 2019, and the universe tossed us another curveball. 2I/Borisov, named after the amateur astronomer Gennady Borisov, who spotted it through his homemade telescope in Crimea. Unlike Oumuamua's stealthy glide, Borisov announced itself with a flamboyant tail, a classic comet spewing gas and dust as it warmed near the sunday. This one came from the Cassiopeia region, barreling through at 44 kilometers per second, its orbit even more exaggeratedly open than its predecessors. Hubble and ground-based scopes revealed a nucleus about 1 kilometer across, wrapped in a coma rich with cyanide, carbon monoxide, and water stuff we'd expect from our own Oort cloud comets, but with subtle twists. Its deuterium-to-hydrogen ratio matched interstellar clouds, confirming its alien birth. Yet, Borisov had quirks. It fragmented slightly during perihelion, shedding pieces that glowed with unexpected brightness. Scientists pored over spectra, finding diatomic carbon, and even hints of ammonia, painting a picture of a pristine wanderer untouched by any star's heat for billions of years. Gennady's backyard discovery democratized the hunt, proving that you didn't need a multi-million-dollar observatory to snag a piece of the cosmos. But whispers of mystery lingered. Why? The high carbon monoxide levels, more than any solar system comet. Could it hint at formation around a cool red dwarf? Or perhaps ejection from a violent stellar nursery? As Borisov receded, heading toward Telescopium, it became a benchmark, showing interstellar comets could mimic our own, while hiding exotic origins. These early interlopers weren't just flukes. They hinted at a galactic highway teeming with drifters. Estimates suggest billions of such objects roam the Milky Way, ejected by gravitational tugs in their home systems, perhaps during planetary migrations or close stellar flybys. Oumuamua might have been kicked out 400 million years ago from a young star cluster, while Borisov's path traces back to a potential origin near Kruger 60, a red dwarf system. The thrill comes from what they carry: pristine materials from other stellar forges, isotopes, and organics that could rewrite our understanding of how planets form. Imagine Oumuamua as a time capsule, its surface etched with radiation scars from countless cosmic rays, or Borisov's ices preserving molecules predating our sunday. Yet, both escaped detailed scrutiny. Oumuamua was spotted post-perihelion, too late for a close-up, and Borisov fragmented before we could dream of a rendezvous. That's where amateur astronomers shine, extending our reach. Folks like Sam Dean, combing through archival data from surveys like Pan-STARRS and ZTF, unearthed pre-discovery images of Borisov stretching back months, refining its trajectory and revealing early activity. This crowdsourced sleuthing turned solitary skywatching into a global puzzle, fueling forums and papers alike. Building on that legacy, enter 3I/Atlas in 2025, a fresh interstellar comet that feels like the universe upping the ante. Spotted on July 1st by the Atlas survey in Rio Hurtado, Chile, a network of robotic telescopes hunting for near-Earth threats. This speck of light moved with purpose, clocking 135,000 miles per hour. Initial calculations pegged it as hyperbolic, unbound to the sun, marking it as our third confirmed outsider. Pre-discovery digs pushed sightings back to June 14th, giving us a longer baseline to map its journey from Sagittarius. Unlike Oumuamua's barren profile, Atlas boasts a coma and tail, glowing with cyanide and nickel vapors, but curiously iron-poor, a chemical fingerprint that doesn't match our local comets. Spherex spectra from August showed CO2 fog and water ice, evoking Mars's thin atmosphere more than a distant nebula. Its size? Tricky, fluctuating between 1 and 10 kilometers due to outbursts. But Hubble's July 21st shots revealed a teardrop nucleus with jets spewing rhythmically. R.V. Loeb, ever the provocateur, revisited his theories in a September paper, noting Atlas's retrograde incline of 175 degrees counter to our planet's spin as potential evidence of deliberate navigation. What if it's not random? Its path skims inside Mars's orbit at perihelion on October 30th, close enough for a Martian peak without risking collision. The discovery of Atlas underscores how technology has transformed the hunt. Atlas, funded by NASA, scans the skies nightly, using AI to flag anomalies amid billions of stars. Its Chilean outpost, perched in the clear Andes air, caught Atlas as a faint magnitude 18 dot. But follow-ups from Mauna Kea and La Palma exploded the data trove to over 100 observations. Amateur contributions poured in. Enthusiasts like those in the Comet Chasers project snapped tail measurements, While online sleuths on platforms like Reddit dissected light curves for hidden patterns, one viral thread analyzed a color shift from red to green during a lunar alignment, attributing it to cyanide excitation but speculating on plasma interactions. This blend of pro and hobbyist efforts echoes Borisov's story, where Gennady's modest setup beat billion-dollar arrays to the punch. For Atlas, the payoff is real-time. As it hurtles inward, brightness spikes could make it naked eye visible by December, a gift for backyard stargazers worldwide. Diving deeper, Atlas's composition tantalizes with implications for life's origins. Its nickel-cyanide mix recalls meteorites linked to prebiotic chemistry, while absent iron suggests formation in a metal-depleted environment, perhaps around an ancient population 2 star. Compared to Borisov, which oozed CO like a leaky engine, hinting at carbon-rich birthplaces, Atlas leans CO too heavy, mirroring Venusian or Martian volatiles. Could it be debris from a terraformed world gone awry, or a natural courier of panspermia seeds? Loeb's Bayesian priors crunch the odds, with anomalies like an anti-tail dust streaming forward, defying solar wind. The artificial hypothesis creeps in at 1 in a million, but non-zero. Ground-based polarimetry from September 5th, detailed in an Ars-IV preprint, showed extreme negative polarization, a dust behavior seen in active comets but amplified here, as if the grains are unusually aligned. This could stem from magnetic fields in its core, natural or otherwise. Linking back to Mars, Atlas's flyby on October 3rd offers a unique vantage. Orbiters like NASA's MRO and ESA's ExoMars could snag high-res images, resolving features down to meters, better than Hubble from Earth. Spectrometers might sniff organics evaporating in the coma, tying into Perseverance's quest for ancient life signs in Jezero crater. Imagine, if Atlas sheds material, faint meteors could streak Martian skies, depositing interstellar dust for future rovers to sample. This convergence feels serendipitous, bridging local exploration with galactic wanderers. The evolution from Oumuamua's surprise to Atlas's anticipated passage shows our growing prowess. Early detections now allow mission planning. An Ars-IV paper from July 21st explores flyby feasibility, proposing a CubeSat swarm launched from Mars to intercept. ESA's Comet interceptor, set for 2029, waits in the wings for the next visitor, armed with probes to sample directly. Yet, the human element endures. Amateurs like those who refined Oumuamua's spin rate through light variations keep the field vibrant, reminding us that curiosity isn't confined to labs. As we trace these interstellar threads, patterns emerge. Oumuamua's acceleration, Borisov's fragmentation, Atlas's chemical quirks, all puzzle pieces in a vast mosaic. Perhaps they're scouts from the galaxy's fringes, or relics of long-extinct stars. The tingle of possibility keeps us gazing up, wondering if the next one brings answers or more riddles. From Hawaii's peaks to Crimea's backyards, and now Chile's valleys, each discovery shrinks the universe, making the infinite feel a bit more intimate. Speaking of gazing up from different corners of the world, where are you tuning in from right now? And what time is it there? Maybe the middle of the night in Sydney or early morning in London. Atlas, with its Martian brush, might just be the chapter that ties it all together. A cosmic handshake between worlds, nestled in the cold embrace of space. Mars has long beckoned humanity with its rusty allure, a world that whispers secrets of ancient rivers and vanished oceans, challenging us to unravel whether life ever stirred in its crimson soils. This enigmatic neighbour, the fourth rock from the sun, isn't just a barren desert today. It's a frozen snapshot of a vibrant past where liquid water carved canyons deeper than Earth's Grand Canyon, and lakes pooled in craters vast enough to swallow countries. Billions of years ago, Mars mirrored our own blue planet. A protective magnetic field warded off solar winds, an atmosphere thick with greenhouse gases trapped warmth, and hydrothermal vents bubbled with chemical soups that could have sparked the first sparks of biology. But something cataclysmic shifted around 3.7 billion years back. The planet's core cooled, its magnetic shield flickered out, and relentless solar blasts stripped away the air, turning lush valleys into icy wastelands. Today, Mars is a ghost of that era. Its thin carbon dioxide veil offering scant protection from cosmic rays, with temperatures plunging to -90 degrees Celsius at night. Yet, this harsh realm captivates, not despite its desolation, but because of the tantalizing clues it holds. Could microbial ancestors have thrived here, only to retreat underground or fossilize in the regolith? And now, with an interstellar comet like 3I/Atlas poised for a close brush on October 3rd, 2025, Mars becomes the stage for a cosmic convergence where local relics meet galactic nomads. The human fascination with Mars traces back to the 19th century, when Italian astronomer Giovanni Schiaparelli peered through his telescope and sketched what he called canali, linear features he thought were channels, perhaps engineered by intelligent beings to irrigate a dying world. American Percival Lowell seized on this, mapping intricate networks and fueling wild speculations of Martian civilizations battling drought. These canals turned out to be optical illusions, tricks of low-resolution optics, and wishful thinking, but they ignited a cultural firestorm. H.G. Wells's War of the Worlds depicted invading Martians, while Edgar Rice Burroughs spun tales of princesses on Barsoom. Fast forward to the space age, and probes began piercing the veil. The Mariner missions of the 1960s revealed a cratered, lifeless expanse, dashing dreams of verdant cities but unveiling volcanic giants like Olympus Mons, taller than Everest, thrice over. Then came Viking in 1976, twin landers that scooped soil and ran experiments hunting organic life. The results? Ambiguous at best, gases bubbled, but no clear biosignatures emerged, leading many to shelve Mars as a dead end for 2 decades. Yet, those early disappointments planted seeds of persistence, teaching us that life's traces might hide in subtler forms, like mineral veins or isotopic quirks. Revival struck in the late 90s with Pathfinder, a plucky probe that deployed Sojourner, the first rover to trundle across Martian dirt. This golf cart-sized explorer analyzed rocks, confirming volcanic histories and hinting at past floods. But the real game changers were Spirit and Opportunity. In 2004, twin rovers designed for 90-day jaunts that endured for years. Spirit unearthed silica deposits from ancient hot springs, environments where earthly microbes thrive, while Opportunity stumbled upon hematite blueberries, spherules formed in water, proving that briny seas once lapped Martian shores. These findings electrified the world, shifting Mars from a sterile rock to a once habitable haven, drawing billions in public attention and inspiring a new generation of dreamers. By 2012, Curiosity landed in Gale Crater, a nuclear-powered beast equipped to sniff out habitability. It drilled into mudstones, detecting organics like chlorobenzene and sulfur compounds, alongside evidence of neutral pH waters, conditions ripe for life 3.5 billion years ago. Curiosity's longevity, still roaming as of 2025, underscores humanity's growing knack for remote survival in alien extremes. Enter Perseverance, the rover that elevates this legacy to new heights. touching down on February 18, 2021, after a nail-biting descent dubbed the 7 Minutes of Terror. Picture it. Hurtling through Mars's atmosphere at 12,000 miles per hour. The spacecraft shed its heat shield amid flames, deployed a supersonic parachute, then fired retro-rockets to hover while lowering the rover on nylon tethers. A sky crane ballet never attempted before. Touchdown in Jezero crater sent cheers echoing through mission control, with the first grainy images beaming back, a stark landscape of deltas and dunes, remnants of a 3.5 billion-year-old lake. This site wasn't chosen lightly. Orbital scans showed layered sediments rich in clays, carbonates, and olivines, minerals that preserve life's fingerprints on Earth. Perseverance, built on Curiosity's chassis but upgraded for astrobiology, packs 23 cameras, including zoom lenses for eagle-eyed scouting and a suite of spectrometers to zap rocks from afar. Its French-American supercam laser vaporizes samples up to 23 feet away, analyzing plasma glows for elements like carbon or phosphorus, while the Spanish MEDA station monitors dust storms and radiation, painting daily weather portraits. What sets Perseverance apart is its quest for biosignatures, those subtle echoes of biology etched in stone. In July 2024, it drilled into Chayava Falls, a veined rock with leopard-like spots, organic rings rimmed by hematite, suggesting redox reactions where microbes might have feasted on iron. Recent analyses, published on September 10, 2025, in Nature, bolster this intrigue. The rover's Pixel instrument detected sulfate minerals and organics intertwined, patterns mirroring Earth's microbial mats in hydrothermal vents. Scientists caution, it's not proof abiotic processes could mimic this, but it's the strongest hint yet, with Canadian researchers contributing isotopic data hinting at biological fractionation. Imagine ancient bacteria thriving in Jezero's shallows, their metabolisms oxidizing iron for energy, leaving these freckles as tombstones. Perseverance has cached over 24 samples in titanium tubes, dropping them like breadcrumbs for future retrieval. A trail that could confirm life's Martian chapter if brought home. Beneath its wheels, Mars's geology unfolds like a thriller novel. Jezero's floor, once a delta fed by rivers, holds stratified layers. Bottom muds from calm lakes, topped by sands from turbulent flows. Ground-penetrating radar rimfax peers 10 meters deep, mapping subsurface structures, perhaps aquifers frozen in time, harboring dormant microbes. The rover's journey, now over 20 kilometers, has traversed Saïta dunes and Aitken Basin outcrops, each revealing twists. Volcanic basalts, laced with peridotite, hinting at mantle upwellings, and phyllosilicates clays that trap organics like time capsules. September 2025, updates from NASA's Mars report highlight a fresh find. A boulder with polygonal cracks, evocative of desiccation patterns in Earth's playas, where microbes encrust salts. Could these be fossilized biofilms? The data teases, with Sherlock's ultraviolet scans glowing with aromatic hydrocarbons building blocks of life, or just cosmic contaminants. Perseverance isn't alone in this detective work. Its companion, Ingenuity, the helicopter that defied Mars's razor-thin air, has flown over 70 times by 2025, scouting ahead like a aerial sleuth. Weighing just 4 pounds, with counter-rotating blades spinning 2,400 revolutions per minute, it braved -90-degree nights and dust devils, capturing vistas of hidden gullies and potential sample sites. One flight revealed the rover's own parachute remnants, a poignant reminder of arrival, while others mapped routes avoiding boulder fields. This duo embodies innovation. Perseverance's MOXIE experiment, a toaster-sized device, has produced over 100 grams of oxygen from carbon dioxide by September 2025, proving in situ resource utilization. For future astronauts, breathable air from thin Martian skies, tying this to the approaching 3I/Atlas. Perseverance's perch in Jezero positions it as an unwitting observer. On October 3, 2025, as the comet skims 30 million kilometers away, close enough for orbital eyes like Mars Reconnaissance Orbiter to snag detailed spectra, any expanded coma might dust Mars's atmosphere, potentially seeding organics detectable by the rover's sniffers. Live science reports from September 11th suggest Atlas's green tint from dicarbon dissociation could indicate volatile mixes akin to Martian ices. What if this interstellar flyby stirs dormant clues? Avi Loeb's recent YouTube musings speculate. If Atlas harbors exotic organics, it might echo materials that bombarded early Mars, kickstarting biology. Perseverance's latest redox findings, detailed in Nature, show iron-sulfur clusters in samples compounds that on Earth fuel primitive metabolisms, perhaps delivered by cometary impacts. This interplay fuels endless curiosity. Mars, once wet and warm, lost its vitality, but comets like Atlas remind us of the galaxy's churn, flinging ingredients across voids. September 2025 Science Daily highlights Perseverance unveiling. Shifting conditions from alkaline lakes to acidic flows mirroring Ethiopia's Danakil Depression, where extremophiles endure pH extremes. French collaborators on SuperCam, firing over 10,000 laser shots, have mapped manganese oxides, hints of oxygen-rich epochs when microbes might have oxygenated waters. The rover's arm, with its coring drill, has sealed tubes with regolith from Enchanted Lake, a site with hydrated silicas, Earth analogues for opal hot springs teeming with life. As Perseverance climbs Jezero's rim by late 2025, eyeing volcanic terrains, it probes deeper mysteries. Subsurface radar echoes suggest briny pockets, potential refuges for hardy organisms. CBC Kids News from September 15th notes the strongest evidence yet, with public excitement surging viral videos of simulated ancient Mars, rivers flowing under pink skies, yet caution prevails. Fact checks from Yahoo News debunk exaggerated claims of life found, emphasizing biosignatures need Earth labs for verification. The Mars Sample Return mission, slated for the 2030s, looms as the ultimate arbiter, with European rovers fetching those tubes. In this red world's embrace, Perseverance embodies our unyielding quest, a mechanical pioneer bridging eras. Its wheels churn dust that might hold microbial ghosts, while overhead, Atlas's flyby adds a galactic twist. Could interstellar seeds have fertilized Mars's cradle? The rover's weather logs from MEDA show dust devils swirling, perhaps carrying traces from afar. September's New York Times piece describes the clearest sign in Chayava's veins, with organics preserved in olivine crystals that on Earth entomb ancient bacteria. This rover, powered by plutonium decay, outlasts storms that felled predecessors, its autonomy dodging hazards with AI vision. Ultimately, Mars, through Perseverance's lens, isn't a dead end, but a mirror, reflecting Earth's fragility and the universe's vast potential. As Atlas nears, the red planet stands ready, its secrets poised to intertwine with cosmic drifters, inviting us to ponder what hidden chapters await in the dust, deep within the ancient sediments of Jezero crater, where Mars's dusty winds whisper over billion-year-old layers of clay and mud. NASA's Perseverance rover unearthed a puzzle that could redefine our place in the cosmos. A rock veined with what might be the fingerprints of primordial life. Dubbed Chayava Falls after a majestic Earth waterfall, this arrowhead-shaped slab spotted on July 21, 2024 bears enigmatic leopard spots, dark rims encircling white splotches rich in calcium sulfate, as detailed in NASA's September 10, 2025 press conference. These features scream of chemical intrigue. Organic compounds intertwined with iron and phosphate minerals, suggesting reactions that, on our planet, often stem from microbial munching. Picture tiny ancient bacteria thriving in a shallow Martian lake, oxidizing iron for energy and leaving behind these mineral tattoos. These could be abiotic tricks, forged by hydrothermal vents, or radiation without a single cell involved. The rover's Sherlock instrument scanned the veins, detecting polycyclic aromatic hydrocarbons, carbon rings, that form life's backbone or emerge from sterile chemistry. This duality keeps the tension alive. Is Chayava a biosignature, a clue that Mars once buzzed with microbes, or just a geological red herring? The discovery's timing, amplified in the Mars Report Special Edition on September 10, 2025, aligns with Perseverance's climb up Jezero's western rim, a trek revealing shifting conditions as reported in Science Daily on September 18th. Drilling into a mudstone core exposed vivianite, a phosphate mineral tied to organic decay, and greigite, a magnetic sulfide often produced by bacteria reducing sulfate. Times of India highlighted this on September 17th, noting textures evocative of Earth's microbial mats. Layered biofilms where organisms trap sediments. Yet, Big Think's September 17th article cautions, organics abound in space, birthed from simple reactions like those in meteorites or nebulae. Why assume life when chemistry suffices? This debate fuels the curiosity. Perseverance's pixel X-ray scans showed leopard spots aligned along redox boundaries, where electrons danced between oxidized and reduced states, a hotspot for biology on Earth. Imagine if these spots formed 3.8 billion years ago, when Mars's lakes teemed with possibilities, before the atmosphere thinned and waters froze. To grasp the thrill, consider Jezero itself, a 45-kilometer wide basin sculpted by an asteroid impact 4 billion years ago, later filled by a river delta depositing sediments in fan-shaped lobes. Orbital maps from Mars Reconnaissance Orbiter guided the rover here, spotting carbonates and clays minerals that excel at preserving organics. Perseverance's journey, now spanning over 30 kilometers by September 2025, has sampled diverse terrains. The crater floor's igneous basalts, laced with olivine crystals that could entomb ancient molecules, and delta fronts with hydrated silicas, akin to opaline hot springs on Earth, where silica encases microbes like natural amber. A Texas A&M geologist, quoted in their September 10th release, points to these as potential biosignatures, with isotopic ratios hinting at biological fractionation. Lighter carbon isotopes concentrated, a hallmark of life preferring easier bonds. But skepticism persists. Space.com's September 10th piece notes similar signatures in abiotic lab simulations, urging sample return for definitive tests. This rover's toolkit turns speculation into science. Its robotic arm, wielding a coring drill, has extracted 43 samples by mid-September 2025. Sealing them in ultra-clean titanium tubes to avoid contamination. The caching system, a marvel of engineering, processes cores with volume checks and hermetic seals, dropping depots like breadcrumbs across the landscape. 3 sites so far, including one at Three Forks, with duplicates for redundancy. NASA's plan: a future Mars sample return mission, launching in the late 2020s. Where a European rover fetches the tubes, loads them into a rocket that blasts off Mars's surface, a first for humanity, and rendezvous with an orbiter for the Earthward trip. Reuters' September 10th coverage emphasizes the stakes. Labs here could deploy electron microscopes and mass spectrometers, dissecting organics at atomic levels to distinguish biotic from abiotic. What if Vivianite in Chayava holds amino acids, life's precursors, or chiral molecules twisted in life's preferred handedness? Drawing parallels to Earth amps the intrigue. In Ethiopia's Danakil Depression, extremophiles, heat-loving archaea endure 120 degrees Celsius vents and pH swings, metabolizing iron and sulfur, much like hypothesized Martian bugs. Lopez Lake's hydrothermal fields, studied by astrobiologists, mirror Jezero's ancient setup. Clay minerals trapping nitrogen and carbon, fostering prebiotic soups. Perseverance's findings, per Science Daily's fresh report, suggest Mars experienced similar shifting conditions from neutral lakes to acidic episodes, potentially allowing life to adapt before the big freeze. Could subsurface pockets, detected by RIMFAX radar, echoes 10 meters deep, still harbor dormant forms? The rover's September 15th data dump, via NASA's portal, shows briny perchlorate signals, compounds that lower water's freezing point, enabling liquid pockets in permafrost. Imagine cryophilic microbes, akin to Antarctica's Blood Falls denizens, surviving in salty veins. Tying this to 3I/Atlas adds a galactic layer. As the comet nears on October 3rd, 2025, its CO2-rich coma, detailed in Sphere-X spectra, echoes Mars' atmosphere, potentially shedding organics during flyby. If dust trails reach the red planet, as modelled in an RCIV preprint from September 12th, they could mimic ancient bombardments that delivered life's ingredients. Perseverance might detect isotopic spikes in atmospheric sniffs via MEDA, linking interstellar chemistry to Jezero's biosignatures. Loeb's September 15th commentary speculates, what if Atlas carries panspermia evidence? Microbes hitchhiking from afar, seeding Mars's lakes. The rover's organic detections, thiophenes and benzenes in delta muds, could match cometary profiles, blurring lines between local evolution and cosmic imports. Delving deeper, Perseverance's astrobiology arsenal uncovers subtleties that tease the mind. The Watson camera captures microtextures, polygonal ridges in rocks reminiscent of desiccation cracks where Earth's microbes form crusts. September's Nature paper analyzes these, finding manganese enrichments, oxidized forms suggesting oxygenic photosynthesis, though Mars's early atmosphere lacked free oxygen. Abiotic? Solar UV could drive it, but biological boosts fit too. The rover's endurance, powered by a multi-mission radioisotope thermoelectric generator yielding 110 watts, allows seasonal studies. Dust storm data from 2025's perihelion season shows opacity drops, enabling clearer laser shots with supercam. French collaborators report over 15,000 zaps, mapping elemental gradients that hint at biofilm layering. Public buzz, as seen in viral X threads from September 10th, amplifies the mystery posts debating life on Mars with memes of alien fossils. Yet, experts like those at JPL stress humility. Biosignatures require convergence, multiple lines like morphology, chemistry, and context. Chayava scores high, located in a habitable zone, with water evidence from delta strata, and organics not easily explained abiotically. A September 16th live science feature explores alternatives, volcanic fluids percolating through cracks, depositing minerals sans life. But the phosphate-iron combo, per Texas A&M, leans biotic, evoking Earth's banded iron formations from microbial blooms. As Perseverance ascends the rim, eyeing Pico Turquino outcrop by late September 2025, it probes volcanic interfaces, lavas over sediments, potential hydrothermal niches, Radar profiles suggest fractured zones, ideal for fluid flow and life preservation. What if the next core reveals stromatolites, laminated structures from microbial trapping? The rover's autonomy, navigating with stereo vision to avoid hazards, has clocked 200 sols of self-drive, uncovering surprises like a popcorn-textured rock, calcium sulfate nodules from evaporating ponds. This quest probes profound questions. If Mars hosted life, did it mirror Earth's with DNA-like codes, or diverge wildly? Perseverance's organics, stable over eons in cold dryness, could hold RNA fragments or lipid membranes. The September 18th Science Daily update ties this to watery past, with delta isotopes indicating prolonged habitability, perhaps 500 million years, enough for complexity. Interstellar links with Atlas intrigue further. Its nickel cyanide vapors, if deposited, could mimic prebiotic inputs. Models suggest cometary impacts 3.5 billion years ago enriched Mars's organics, fueling Jezero's chemistry. Perseverance's samples, if returned, might isotope match such sources, proving cosmic fertilization. In Chayava's veins, we glimpse a mirror Earth's sibling. Life possible, yet lost. As data accumulates, the rover's legacy builds. Not proof, but provocation, urging us to wonder if microbial Martians once gazed at the stars, or if we're the galaxy's lone sentinels. Each finding layers the enigma, keeping the cosmic detective story alive. And if these Martian mysteries have you hooked like they do me, consider subscribing and turning on notifications to catch the next twist in our exploration journey. Whispers of wind across the Martian plains carry more than dust. They echo the hum of rotors slicing through an alien sky, a testament to human audacity in defying the red planet's unforgiving embrace. Ingenuity, the pint-sized helicopter that dared to lift off where no wings had fluttered before, transformed Mars exploration from a ground-bound crawl into an aerial ballet, revealing vistas that ground rovers could only dream of. Weighing a mere 4 pounds, with blades crafted from carbon fiber and foam, this solar-powered marvel contended with an atmosphere just 1% as dense as Earth's, where lift is a scarce commodity, and every flight a calculated gamble against gravity's unyielding pull. Its first hover on April 19, 2021, lasted a mere 39 seconds. Yet it shattered barriers. The Wright brothers' moment reborn on another world, captured in grainy footage that still sends shivers down spines. But what secrets did those early ascents unveil? And how might this tiny flyer's legacy intersect with the approaching shadow of an interstellar comet like 3I/Atlas? Ingenuity's design was born from necessity, honed in the vacuum chambers of NASA's Jet Propulsion Laboratory, where engineers simulated Mars's brutal chill dropping to -90 degrees Celsius overnight and its feeble air pressure, equivalent to Earth's at 100,000 feet. The helicopter's dual rotors, spinning at 2,500 revolutions per minute, generated just enough thrust to defy the planet's 38% gravity, but only in short bursts to conserve battery life. Early tests in JPL's 25-foot space simulator, filled with carbon dioxide and pumped down to near vacuum, revealed vulnerabilities. Vibrations that could shake components loose, or dust clinging to solar panels, starving the craft of power. Yet, these trials forged resilience. By its fifth flight, Ingenuity transitioned from tech demo to operational scout, covering distances up to 1,600 feet in a single bound, its navigation camera snapping stereo images to build 3D maps on the fly. What hidden craters or ancient outcrops might it have overlooked if confined to Perseverance's wheels? The helicopter's autonomy, powered by a Snapdragon processor, allowed it to dodge hazards mid-flight, a feat that sparked questions. Could future drones swarm Mars's skies, mapping vast regions untouched by rovers? As flights accumulated, surpassing the initial goal of 5 to reach 72 by January 2024, Ingenuity's role evolved into a vital partner for Perseverance. It scouted ahead, identifying safe paths through boulder-strewn fields and pinpointing intriguing rock formations, like the fractured hogback ridges in Jezero's delta that hinted at turbulent ancient floods. One memorable sortie, Flight number 26, on April 3, 2022, captured the wreckage of Perseverance's own entry system, the back shell and parachute strewn across the dunes, a poignant reminder of the rover's perilous descent. This imagery not only aided navigation but fueled curiosity about Mars's dynamic surface, how wind reshapes debris over time, potentially burying or exposing geological treasures. Ingenuity's color camera, a late addition, added vibrancy. Shots of layered sediments in South Saïta, revealing hues of ochre and mauve that suggested mineral diversity, from iron oxides to possible organics. But what if those layers hold microbial fossils, glimpsed from above, before the rover's drill ever touches them? Even after its mission concluded following rotor damage on January 18, 2024, detailed in NASA's December 11, 2024 accident report, Ingenuity's influence lingers. The review pinpointed navigation errors in a featureless dune field, leading to a hard landing that snapped blade tips. Yet, the craft remains operational as a stationary weather station, its sensors logging temperature, pressure, and dust levels, contributing to long-term climate models. This pivot raises intriguing prospects. Could Ingenuity's data detect subtle atmospheric changes from incoming cosmic visitors? As 3I/Atlas approaches on October 3, 2025, its coma might perturb Mars's thin veil, stirring dust, devils, or altering pressure gradients phenomena Ingenuity's instruments could capture from its perch. The comet's green tint from dicarbon breakdown, as reported in Live Science on September 11, 2025, suggests volatile releases that could seed trace gases, detectable if Ingenuity's anemometer picks up anomalous winds. Shifting focus to Perseverance's own technological symphony, the rover operates in harmony with Mars's rhythms, syncing to the Martian soul a day stretching 24 hours and 37 minutes. This offset means Earth teams work sliding schedules, planning, drives, and analyses around the planet's unhurried spin. Perseverance's autonav system, an AI-driven marvel, processes terrain images in real time, plotting paths up to 200 meters daily while avoiding pitfalls like soft sand traps or steep slopes. By September 2025, as per NASA's Mars report, the rover has traversed over 37 kilometers, its wheels imprinting tracks that weave through Jezero's history. What untold stories lie in those paths? The SuperCam instrument, a Franco-American collaboration, fires infrared lasers from atop the mast, vaporizing targets up to 23 feet away to analyze their atomic makeup. Over 15,000 shots by mid-2025 have mapped elemental distributions, spotting manganese spikes in rocks that suggest oxidizing environments, potential niches for ancient life. SuperCam's versatility extends to acoustics. A microphone captures the zap's sound, revealing material density through echo patterns, while also recording Martian winds and rover creaks. In one captivating moment on April 3, 2022, it documented Phobos's eclipse, the moon's jagged shadow racing across the sunlit landscape at over 2,000 miles per hour. This footage, detailed in a September 2025 astronomy magazine retrospective, not only showcases orbital dynamics, but sparks wonder. How might such eclipses have influenced early Martian chemistry, perhaps triggering photochemical reactions in primordial pools? Perseverance's Mastcam Z, with its zoom capabilities, complements this by stitching panoramas of Jezero's rim, revealing stratified cliffs, that whisper of episodic flooding, wet epochs interspersed with dry spells, environments where life could have pulsed in cycles. Linking these technologies to the impending comet encounter, orbiters like NASA's Mars Reconnaissance Orbiter and ESA's ExoMars Trace Gas Orbiter stand ready for October 3rd's flyby. MRO's high-rise camera, capable of resolving features as small as a dinner table from orbit, could snapshot 3I/Atlas's nucleus during its 30 million kilometer pass, capturing jets or surface fissures. The comet's estimated 11-kilometer width per psi, news on September 12, 2025, and speed of 130,000 miles per hour make it a fleeting target. But orbital spectrometers might snag molecular fingerprints, water, cyanide, or organics that echo Perseverance's ground findings. What if the rover's MEDA weather suite detects fallout from the comet's tail? Subtle dust infusions altering atmospheric opacity. Ingenuity's post-flight data, as a fixed monitor, could corroborate, tracking pressure dips or temperature anomalies from cometary volatiles. The broader tech ecosystem on Mars amplifies this preparation. Perseverance's RIMFAX radar penetrates up to 30 feet subsurface, mapping layers that could hide aquifers or ice deposits, resources vital for future human missions, but also potential refuges for extant life. By September 18, 2025, as Science Daily reports, the rover's latest analyses from Pinnacle Ridge unveil shifting conditions, with hydrated minerals indicating prolonged water activity. This ties into MOXIE's success. The experiment has generated over 122 grams of oxygen by 2025, electrolyzing carbon dioxide at rates scalable for astronaut support. Imagine bootstrapping a base from Martian air, but what contaminants might comets like Atlas introduce, altering that chemistry? Ingenuity's flights, though ended, inspire next-gen concepts. NASA's Dragonfly, bound for Titan in 2028, borrows its multi-rotor design, while proposed Mars sample return helicopters aim to ferry Perseverance's tubes. The little chopper's 72 flights covered 14 kilometers, enduring dust storms that blanketed solar panels, yet persevered through software tweaks. A CBS News piece from December 11, 2024, details lessons from its crash. Smoother navigation algorithms for future drones, perhaps enabling aerial surveys of Atlas's potential impact zones if fragments stray. Curiosity builds as we ponder integrations. Could Perseverance's arm, with its caching system, one day collect cometary dust? The rover's Sherlock ultraviolet scanner, mapping organics in Chayava Falls, might analyze such extraterrestrial grains, comparing isotopic ratios to Jezero's biosignatures. September 2025's ESA, frequently asked questions on 3I/Atlas, notes its hyperbolic trajectory, inclination hinting at galactic disk origins, a wanderer potentially bearing pre-solar ices. Orbiter's readiness, with reprogrammed instruments, promises data floods. ExoMars's Nomad spectrometer hunting methane spikes from cometary interactions. This technological tapestry weaves a narrative of exploration's edge. From Ingenuity's defiant hovers to Perseverance's laser-eyed scrutiny, tools that probe Mars's secrets now turn outward, eyeing Atlas's approach. What revelations await in that cosmic brush-dusty veils, unveiling shared origins, or anomalies defying explanation? The red planet's guardians stand vigilant, their innovations bridging worlds, inviting us to question the boundaries of possibility. In the shadowy fringes where astronomy meets speculation, the interstellar comet 3I divided by Atlas has ignited a firestorm of debate, pitting rigorous science against the allure of extraterrestrial intrigue. Discovered on July 1st, 2025, this cosmic nomad from beyond our solar system has drawn the gaze of telescopes worldwide, but it's Harvard astrophysicist Avi Loeb who has thrust it into the spotlight of controversy. In a paper released just days ago, on September 17th, Loeb posits that 3I divided by Atlas's unusual properties, its green glow, extreme negative polarization, and iron-poor composition could hint at something artificial, perhaps a probe engineered by an advanced civilization. He argues that the object's retrograde orbit and precise trajectory, skimming inside Mars's path before a close Venus flyby, seem improbably tailored, as if designed for reconnaissance rather than random drift. Loeb's Bayesian analysis crunches the odds. With anomalies stacking up, the probability of alien tech, though slim, isn't 0, perhaps 1 in 1,000, enough to warrant investigation. This isn't Loeb's first rodeo. His theories on Oumuamua in 2017 sparked similar uproar, suggesting that cigar-shaped visitor might be a light sail propelled by alien ingenuity. Now, with 3I divided by Atlas turning heads, he calls for intercept missions, urging NASA to deploy CubeSats from Mars orbit to snag samples during its October 3rd flyby. But is this bold science or sensationalism? Skeptics like astronomer Jason Wright from Penn State dismiss it as premature hype, pointing out that Loeb's claims often leap ahead of data, fueling public misconceptions without solid evidence. Fueling the frenzy are whispers from online forums and social media, where 3I divided by Atlas morphs from celestial rock to interstellar spy. On X, users like @ShepherdAmbellas share videos claiming the comet's tail resembles propulsion exhaust rather than natural dust, speculating it's a cloaked UFO scanning our defenses. Another post from @Artisan, Bogdan echoes this, describing the tail as looking like propulsion than dust, hinting at a nuclear core driving it earthward. Conspiracy threads buzz with tales of plasma shields masking its true form, or even links to recent UFO sightings over Japan's Genkai nuclear power plant, where mysterious lights danced in the sky. Could 3I divided by Atlas be deploying probes? One user, @LGregCon, jokes about a Russian drone turning out to be a null, unidentified flying object, from 3I divided by Atlas, blending humor with paranoia. These narratives draw from historical precedents. Oumuamua's unexpected acceleration led to books and documentaries positing alien sails, while Borisov, in 2019, sparked rumors of biosignals in its cyanide tail. Now, 3I divided by Atlas's green hue, captured in deep imaging on September 7th, evokes sci-fi visions of emerald-powered engines, with Loeb himself noting the color shift as unusual for solar system comets. What if that verdant glow isn't cyanide excitation but a deliberate signal, a beacon from afar? Yet, NASA pushes back firmly, labeling such claims as unfounded. In a response issued 3 days ago, agency scientists emphasize that 3I divided by Atlas exhibits classic cometary traits: a diffuse coma from sublimating ices, a tail elongated by solar wind, and a hyperbolic orbit, confirming its interstellar origin without artificial tweaks. Hubble observations from September 10th reveal extreme negative polarization in its dust, unique among solar comets, but explainable by aligned, fluffy particles scattering light oddly. not alien tech. The iron deficiency? Likely a hallmark of formation in a metal-poor stellar nursery, billions of years old, rather than engineered minimalism. Loeb's PDF query: is the interstellar object 3I divided by Atlas alien technology? Released in July, acknowledges it's probably a comet, but urges scrutiny of its nucleus size. If smaller than expected, it might be artificial. Critics like Michael Shermer, invoking Bayesian priors, argue the base rate for alien probes is vanishingly low. Extraordinary claims demand extraordinary proof, not speculative leaps. Shermer's debates with Loeb highlight this chasm. Science thrives on falsifiability, testing hypotheses against data, while conspiracies often retrofit facts to fit narratives. This tension echoes through history. In 2017, Oumuamua's flat shape and non-gravitational thrust sparked Loeb's alien sail theory, but follow-ups attributed it to hydrogen outgassing from fractured ices. Borisov's fragmentation? Natural thermal stress, not self-destruct. Now, 3I divided by Atlas's anti-tail, a forward-pointing dust stream defying norms, fuels similar whispers. Is it thrust residue, as some X-posts claim, or solar radiation pressure on fine grains? A Japanese event on September 19th, featuring Loeb discussing 3I divided by Atlas alongside UAP experts like Ross Coulthard, promises to dissect these, blending science with policy. Coulthard, known for probing military UFO encounters, might link the comet to unexplained aerial phenomena, like lights over nuclear sites. Could it be surveying Earth's defenses? On X, the buzz intensifies. At Project Bluebeam ties 3I divided by Atlas to Comet Swan C divided by 2025 R2, suggesting both are probes from different galactic quadrants, their tails not natural. At Narayan 2024 shares NASA's debunk of alien spacecraft claims, but questions linger in replies. At Resumo UFO polls, what do you think 3I divided by Atlas is, with options from Comet to UFO? These posts reflect a cultural undercurrent. In an era of deep fakes and distrust, anomalies breed theories. Remember the Panama meteorite video, enhanced to show a venom-like creature, linked by @Smith, Mistata 3I divided by Atlas as a probe, or at QBack13 invoking biblical parables, asking if 3I divided by Atlas fits divine plans. Such ideas proliferate because science's methodical pace leaves room for imagination. Loeb exploits this, arguing we must consider the extraordinary to advance. Science counters with data-driven restraint. NASA's Comet page notes 3I divided by Atlas remains observable until September 2025, its brightness fluctuating from outgassing, not maneuvers. Spheric spectra confirm CO2 and nickel, typical for pristine interlopers, sans iron due to ancient formation. Quaidaugan Venus, coincidental in a chaotic galaxy, not engineered. Shermer's priors emphasize alien tech requires artifacts like unnatural isotopes or signals. Absent here. Loeb admits 3I divided by Atlas is probably not alien, but insists checking anomalies, pushes boundaries, as in his CBS interview last week, linking to Mars. If 3I divided by Atlas were a ship, its flyby might interact with Perseverance, scanning Jezero's biosignatures or depositing probes. X-users speculate plasma shields hiding it from rovers, but science sees opportunity. Orbiters could sample its tail. Comparing organics to Chayava Falls hints, Loeb's Venus proximity suggests a slingshot for Earth return. but models show it exiting post-perihelion on October 30th. This clash captivates because it probes humanity's core fears and hopes. Conspiracies offer agency in Chaos 3I divided by Atlas as harbinger of contact or invasion, while science demands patience. As Loeb debates Shermer-like skeptics, the comet hurtles on, its green aura a riddle. What if it's just ice and rock, or the key to proving we're not alone? The flyby looms, promising answers or more questions. Extending the discourse, consider Bayesian frameworks. Shermer champions. Prior probabilities for alien visits are low given vast distances, but updates with evidence. Loeb's extreme negative polarization paper from September 10th argues 3I divided by Atlas differs from solar comets, perhaps artificially smooth. Critics counter, sample bias, we've only studied local objects. X threads from @CN Sparta RRPRT tie it to Saturn oppositions and UFO footage, speculating cosmic connections. Japanese politicians, in a September 19th Nico broadcast, discuss 3I divided by Atlas, with Loeb linking to Genkai lights, perhaps drone tests or UAP scouts. @Nichuban promotes it, blending occult and tech. Such events democratize debate, but risk misinformation. For Mars tie-in, Perseverance might detect cometary dust, testing if interstellar organics match biosignatures. If Probe, it could ping the rover wild, but Loeb entertains it. Science insists. Hyperbolic quid-out rules control. As 3I divided by Atlas nears, the duel persists. Loeb's intercept call echoes sci-fi, but NASA's ground telescopes suffice. Conspiracies thrive on gaps, green tail as engine flare, or natural cyanide. The truth may lie in between, urging us to watch the skies with wonder and skepticism. And as we all keep our eyes on those skies from wherever we are, drop a note if you feel like sharing where in the world are you listening from. And what's the hour on your clock right now? Perhaps twilight in Paris or noon in Tokyo? Peering into the horizon of space exploration, the Mars Sample Return mission stands as humanity's boldest leap toward unlocking the red planet's deepest enigmas, a multi-billion-dollar odyssey that could finally answer whether life ever flickered beyond Earth. Conceived as a partnership between NASA and the European Space Agency, this endeavor isn't just about hauling rocks across the void. It's a meticulously orchestrated ballet of robotics, rocketry, and risk, aiming to retrieve the precious cores Perseverance has cached in Jezero Crater, and deliver them to terrestrial labs for scrutiny that no rover could match. As of September 2025, the mission grapples with escalating costs, ballooning from initial estimates to nearly $10 billion, prompting innovative proposals like Lockheed Martin's streamlined plan to slash expenses by half through private sector efficiency. What drives this urgency? The tantalizing biosignatures in samples like Chayava Falls, with their organic veils and mineral whispers, demand earthbound instruments, electron microscopes, and synchrotrons to dissect atomic secrets, potentially confirming microbial relics or debunking them as cosmic mimics. The blueprint unfolds in phases, each laced with unprecedented challenges that stir the imagination. First, the sample retrieval lander touches down near Jezero, a behemoth craft carrying the Mars Ascent Vehicle, a slender rocket poised to become the first to ignite from another world's surface. This lander, drawing from Viking-era heritage but infused with modern autonomy, must navigate Mars's treacherous dust storms and thin air to rendezvous with Perseverance's depots. Picture it. A European-built fetch rover, nimble and solar-powered, scuttles across the regolith like a mechanical scavenger, plucking titanium tubes from their breadcrumb trails. Those scattered caches, designed to hedge against mission failures. Once loaded, the ascent vehicle blasts off, punching through Mars's gravity with a solid fuel thrust that must be precise to reach orbital rendezvous. What if a single grain of dust fouls the engines? Or a solar flare disrupts communications mid-launch? These aren't hypotheticals, they're the razor edges engineers at JPL and ESA sharpen against, testing prototypes in Earth's deserts to simulate the unforgiving Martian chill orbiting above. The Earth return orbiter awaits, a Sentinel craft equipped with capture mechanisms to snag the sample canister in a cosmic game of catch. This phase, slated for the late 2020s if funding holds, involves a basketball-sized pod hurled into space, where the orbiter must locate it amid the void, relying on beacons and LiDAR for a pinpoint grab. The journey home spans months, the orbiter shepherding its payload through radiation belts and gravitational slingshots, finally parachuting into Utah's desert for recovery. But here's where curiosity spikes. What contaminants might hitch a ride? Biological containment looms as a paramount hurdle, with protocols demanding samples be treated as potential biohazards sealed in triple-layered vaults to prevent any Martian microbe from sparking a planetary panic. NASA's Planetary Protection Guidelines, updated in 2024, mandate isolation labs akin to those for Ebola, ensuring no escape while scientists probe for life signs. Imagine the isolation risks. Technicians in hazmat suits, airlocks humming, all to safeguard Earth from an invisible invader that might not even exist. Yet, the payoff? Definitive proof of extraterrestrial biology could shatter paradigms, revealing shared origins or divergent evolutions. Amid funding fights in Washington, where the mission's price tag has doubled, stalling progress, as reported in mid-2025, the quest persists, buoyed by recent biosignature announcements that underscore its necessity. Without sample return, those leopard-spotted rocks remain tantalizing teases. With it, we could sequence ancient DNA analogues or trace isotopic anomalies to stellar nurseries. Private ventures, like Lockheed's $3 billion alternative unveiled in July 2025, propose leaner architectures, perhaps skipping the lander for direct rover handoffs to expedite the timeline. Could this hybrid model, blending government oversight with corporate agility, become the blueprint for interplanetary logistics? The debate simmers, with critics warning of corners cut on safety, while proponents eye accelerated discoveries. Transitioning from sample retrieval to sustaining life on Mars, Perseverance's MOXIE experiment offers a glimpse into self-sufficiency that could underpin human footholds. This toaster-sized wizard, concluding its run in 2023 after 16 cycles, didn't just produce a token 50 grams of oxygen. It amassed 122 grams total, equivalent to a small tree's daily output, by electrolyzing carbon dioxide at rates up to 12 grams per hour. Recent analyses, shared in MIT's 2025 retrospectives, highlight its efficiency. Operating in Mars's variable conditions, MOXIE adapted to dust-laden air and sub-zero nights, proving scalable tech for larger arrays that could fuel rockets or replenish habitats. What intrigues most? Its solid oxide electrolysis cells, heated to 800 degrees Celsius, split CO2 with near-perfect purity, nearly 100% oxygen after flushing impurities, hinting at industrial-scale plants powering ascents for crews. Envision astronauts arriving in the 2030s, deploying MOXIE descendants to stockpile thousands of kilograms of propellant, slashing launch masses from Earth, and enabling round-trip voyages. Complementing this, Perseverance's Meda weather station paints dynamic portraits of Mars's climate, logging pressure dips, dust devils, and radiation fluxes that inform habitat designs. By September 2025, MEDA's datasets reveal seasonal patterns, dust storms peaking in perihelion, reducing solar efficiency by up to 70%, guiding engineers toward nuclear backups or shielded panels. Meanwhile, RIMFAX's ground-penetrating radar delves 30 feet deep, mapping regolith structures for stable foundations or hidden ices. Recent scans from Pinnacle Ridge, detailed in Science 2025, uncover fractured basalts and briny layers, potential water sources, but also quake hazards. Could these insights avert a habitat collapse or reveal aquifers teeming with extremophiles? The data tantalizes, bridging robotic precursors to boots-on-ground realities. Now, casting eyes outward, the October 3rd, 2025 flyby of 3I divided by Atlas promises a data bonanza that could illuminate interstellar chemistry's role in Mars's ancient habitability. This 11-kilometer wanderer, racing at 210,000 kilometers per hour, will skim 29 million kilometers from Mars, close enough for orbiters like Mars Reconnaissance, Orbiter's HiRISE, to resolve its nucleus, potentially spotting jets or craters that betray its origins. X posts from September buzz with anticipation. Users track its green glow from dicarbon emissions, 8 times richer in CO2 than typical comets, fueling speculations of exotic births. NASA's Eyes on the Solar System tool lets enthusiasts simulate the encounter, visualizing its hyperbolic arc past Mars before perihelion on October 29th. What might spectra reveal? Organics like cyanide and nickel, absent iron, could match prebiotic deliveries that seeded Jezero's lakes billions of years ago, linking galactic drifters to biosignatures in Perseverance's caches. If dust trails graze Mars's atmosphere, as modelled in recent ARSIV papers, they might deposit traces detectable by future landers, probing panspermia's viability. This flyby isn't isolated. It's a prelude to ESA's Comet interceptor, launching in 2029 aboard Ariane 6 alongside the Aerial Telescope. Poised at the Sun-Earth L2 point, this trio of spacecraft mothership and 2 probes will idle for up to 3 years, awaiting a long period or interstellar comet for a rapid intercept. Redwire's onboard computer, delivered in May 2025, ensures agile navigation, while instruments like the Dust Impact Sensor and Plasma Analyzer promise close-up assays of pristine ices. Unlike Rosetta's chase of 67P, Interceptor targets the unknown, a dynamically new comet, perhaps like 3I divided by Atlas, offering snapshots of Oort cloud relics or extrasolar exiles. Abstracts from EPS-CDPS 2025 highlight its potential. Flybys at 500 kilometers, dissecting comas for biomolecules that could parallel Mars's organic hints. What if it snags an interstellar interloper, unveiling compositions that rewrite formation theories? Weaving these threads, future missions like MSR and Interceptor embody a symbiotic push, ground truths from Mars's past, fueling quests into the interstellar now. Amid 2025's funding limbo for MSR, paused work, and congressional wrangling, the biosignature buzz from September 10th reignites calls for acceleration. Private plans, like Lockheed's, envision cost-capped variants launching by 2028, potentially overlapping Interceptor's vigil. Human prep escalates too. Moxie's legacy inspires ISRU prototypes for Artemis, while MEDA and RIMFAX data refine suits against radiation spikes, up to 1 sievert per storm, demanding shielded habitats. Speculation abounds. If MSR confirms life, does it echo 3I divided by Atlas's chemistry, suggesting universal seeding? X threads ponder the comet's Mars buzz, 24 days away, as of September 9th, as a probe's reconnaissance, with trajectory tweaks hinting intelligence. Brandenburg's assessments fuel this, noting improbable paths and planetary compositions. Yet, mainstream views hold it's natural, it's anti-tail from radiation pressure. Interceptor could settle such debates, sampling analogues for technosignatures like unnatural isotopes. As timelines converge MSR's return in the 2030s, Interceptor's hunts yielding data by 2032, the cosmos beckons with intertwined fates. Will samples unveil Martian microbes, their DNA kin to Earth's, or alien codes? Could cometary organics match, proving panspermia? Containment fears add drama. Protocols for biorisks, isolating returns in BSL-4 labs, evoke Andromeda strain vibes. Human missions loom. With MOXIE-scaled plants producing tons of oxygen, RIMFAX-guided digs unearthing resources. This era pulses with potential. Funding battles resolved, perhaps by hybrid models. Accelerating revelations. Imagine 2030. Samples analyzed, comets intercepted. Humans stepping onto Mars armed with interstellar insights. What paradigm shifts await life's ubiquity, or our solitude? The missions tease their futures a canvas of wonder, urging us to chase the unknown with unquenchable curiosity. Behind the veil of international borders, a symphony of collaboration orchestrates humanity's gaze toward the stars, where agencies like NASA and the European Space Agency, ESA, weave their expertise into a tapestry of discovery that spans continents and cultures. This partnership, forged in the fires of shared ambition, has propelled missions that transcend national pride, turning the cosmos into a communal frontier. Take the Mars Sample Return campaign, a testament to this unity. NASA's Perseverance rover, diligently caching rock cores in Jezero crater, relies on ESA's engineering prowess for the Fetch rover that will one day gather those treasures, loading them onto a Mars ascent vehicle for the historic first launch from another planet. As costs soar nearly $10 billion by mid-2025, this alliance adapts, blending American innovation with European precision to redefine what's possible. But what hidden gems might those samples hold? And how could they reshape our understanding of life's origins if an interstellar visitor like 3I divided by Atlas carries echoes of similar chemistry from afar? At the heart of this cooperation lies the SuperCam instrument on Perseverance, a Franco-American marvel that exemplifies cross-Atlantic synergy. Developed jointly by France's CNES and Los Alamos National Laboratory, SuperCam's laser zaps Martian rocks from up to 23 feet away, analyzing vaporized plasma for elemental clues, while its microphone captures the planet's eerie sounds, winds howling through canyons, or the rover's own mechanical hums. By September 2025, SuperCam has fired over 15,000 shots, mapping manganese enrichments that hint at ancient oxidizing environments, potentially microbial hotspots. This tool doesn't just collect data, it bridges worlds. With French scientists in Toulouse collaborating real-time with NASA's Jet Propulsion Lab to decode Jezero's geological narrative. Imagine the thrill. A laser pulse revealing phosphate minerals intertwined with organics, sparking debates on whether these are life's relics or mere chemical artifacts. And as 3I divided by Atlas hurtles closer, set for its October 3rd flyby, could SuperCam detect atmospheric perturbations from the comet's dust trail, blending Martian ground truth with interstellar whispers? ESA's role amplifies this narrative, extending from Mars to the broader solar system. Their ExoMars program, a joint venture with Roscosmos but resilient amid geopolitical shifts, deploys the Trace Gas Orbiter to sniff out methane plumes, elusive signs of geological or biological activity. In 2025, this orbiter stands ready for 3I divided by Atlas's approach. Its spectrometers poised to capture molecular signatures from the comet's coma which spans over 348,000 kilometers in near-infrared views. What volatile secrets might it unveil? Water, ice, cyanide, or nickel vapors that mirror primordial soups? ESA's JUICE mission, en route to Jupiter's moons, plans opportunistic observations of the comet in November, using cameras and particle sensors to probe its dusty envelope. This isn't mere opportunism, it's strategic harmony, with ESA's data complementing NASA's, painting a fuller portrait of an object billions of years old, ejected from a distant stellar nursery. NASA's Hubble Space Telescope, a cornerstone of this international effort, captured 3I divided by Atlas on July 21, 2025, revealing a teardrop-shaped coma cocooning its nucleus, estimated between 1 and 5.6 kilometers wide. Processed images from enthusiasts like Thomas Thomopoulos on X showcase this in synthetic color, highlighting the comet's bright core fading into reds and blues. A visual feast that sparks wonder. Is that green glow from cyanide excitation, or something more exotic? Hubble's ultraviolet spectroscopy, planned for November, could discern sulfur to oxygen ratios, clues to the comet's birth environment. Meanwhile, the James Webb Space Telescope, JWST, ANASAES, a Canadian collaboration, observed on August 6th with its near-infrared spectrograph, yielding spectra rich in carbon dioxide, 8 times more than typical comets, prompting questions about its formation around a cool red dwarf or in a metal-poor galactic disk. A preprint from the team teases unexpected results. Polycyclic aromatic hydrocarbons, perhaps, life's building blocks drifting from afar, adding layers. NASA's SphereX mission, launched in 2025, detected water ice and CO2 fog in mid-August observations, extending the coma to 348,000 kilometers, a vast halo visible only in infrared. This all-sky surveyor, designed for galaxy mapping, pivoted to capture the comet's volatile bursts, its data syncing with ESA's contributions for a multi-dimensional view. What if these emissions interact with Mars's atmosphere during the flyby, depositing tracers for Perseverance to sniff? The rover, as NASA's eyes on the surface, could detect isotopic anomalies via MEDA, linking interstellar delivery to Jezero's biosignatures. This global chorus extends beyond agencies to the amateur community, whose contributions democratize discovery. On X, users like @Soraya0109 share Hubble images of 3I divided by Atlas's dusty haze, crediting NASA divided by ESA for the raw data, while adding their analyses dust plumes pointing to rhythmic jets. Kenyan researcher Gerald Leperio, @Leperio, posts daily updates, questioning light curve observations and shape geometry, drawing parallels to Oumuamua while tagging NASA and ESA for insights. His threads from September 16th buzz with global anticipation. New curiosity of science, the third interstellar object, Comet. 3I divided by Atlas, placing interstellar map onto number Earth's global media headlines. Amateurs like Thomopoulos process Hubble data into colorful crops, revealing the comet's anti-solar plume, fostering viral discussions that reach millions. These grassroots efforts, amplified on platforms like X, feed back into official channels. NASA's Eyes on the Solar System app incorporates user queries, simulating the flyby for public engagement. The viral wave on X underscores the event's global ripple. Posts from @2Yodo India in Hindi discuss 3I divided by Atlas's approach, blending cultural perspectives with science, while @Explore Galaxia shares JWST's NERSPEC data, noting the comet's unexpected CO2 dominance. @Then Nerduino streams, analyses, pondering intercept feasibility with SWORI studies, igniting debates on whether CubeSats from Mars could chase it. This digital ecosystem, where amateurs tag pros, accelerates knowledge flow. ESA's frequently asked questions on 3I divided by Atlas, updated September 8th, addresses public queries on JUICE observations, crediting community alerts. What untapped insights might emerge from a Kenyan backyard telescope or an Indian app user's simulation? Broader impacts resonate worldwide, educating and inspiring. NASA's Mars exploration program, intertwined with ESA's ExoMars, fosters youth programs like Kenya's Discover with Leperayo, where Leperayo's posts bridge local curiosity to global missions. In Europe, ESA's HERA mission, gravity assisting at Mars in 2025, ties into Comet studies, observing Deimos en route. Globally, this cooperation combats isolationism, as seen in climate observation pacts, emphasizing shared space for Earth science. 3I divided by Atlas's flyby could spark educational surges, schools simulating orbits, or virtual reality tours of its path, fostering STEM in underserved regions. Yet, challenges lurk. Geopolitical tensions, like those affecting Roscosmos-ESA ties, test resilience, but triumphs like the International Space Station endure. NASA's ice mapping intent with partners, signed in 2021, evolves into 2025 collaborations on Martian resources. For 3I divided by Atlas, multiple assets converge. Hubble's size estimates, Webb's spectra, SphereX's ice detections all shared across borders. Perseverance, as the surface sentinel, integrates this. Its data on Jezero's clays could contrast with Comet organics, probing panspermia. This fusion evokes Tomor. If 3I divided by Atlas's CO2 coma mirrors Mars's air, did similar visitors seed life? Amateur photos from September 17th show evolving brightness outbursts, hinting at hidden activity. Global teams analyze, from Chile's Atlas discovery to Europe's VLT confirmations of cyanide and nickel. TESS's early detections from May suggest pre-discovery activity, extending the observational window. The event's climax on October 3rd promises a data deluge. Orbiters like MRO snapping high-res shots, combining with ground telescopes for 3D models. What asymmetries might reveal natural jets or anomalous propulsion? Viral X posts predict naked eye visibility by December, democratizing awe. Ultimately, this cooperation isn't just technical. It's a beacon of unity, educating billions on our cosmic place. As 3I divided by Atlas brushes Mars, Perseverance's eyes and orbital ears unite data streams, potentially rewriting origins stories. What revelations await in that interstellar handshake? Proof of universal chemistry or a glimpse of solitude? The alliance holds the key, inviting all to ponder the stars' shared secrets. Gazing upward on a crisp autumn night in September 2025, with the faint streak of an interstellar comet like 3I/Atlas etching its path across the sky, humanity confronts a riddle that has haunted philosophers, scientists, and dreamers for millennia. Are we, this fragile spark of consciousness on a pale blue dot, the sole inhabitants of an infinite cosmos? The question isn't merely academic. It's a profound existential probe that stirs the soul, challenging our sense of purpose and place. If the universe teems with life, why the deafening silence? And if we're alone, what does that imply about our stewardship of this lone oasis? As NASA's Perseverance rover drills deeper into Martian secrets, unearthing potential biosignatures in rocks like Chayava Falls, and as 3I/Atlas hurtles toward its close Martian encounter on October 3rd, These inquiries gain fresh urgency, blending hard science with the soft glow of wonder. This enigma, often encapsulated in the Fermi paradox, poses a stark contradiction. The universe is vast. Our Milky Way alone harbors hundreds of billions of stars, many orbited by planets in habitable zones, yet we detect no signs of extraterrestrial civilizations. Named after physicist Enrico Fermi, who reportedly quipped, "Where is everybody?" during a casual lunch in 1950. The paradox has evolved into a multifaceted puzzle. Recent theories, as explored in a March 2025 article from the Genetic Literacy Project, suggest that while the building blocks of life, water, organics, and energy sources are commonplace, the leap to complex, intelligent beings might involve hard steps that are exceedingly rare. The hard steps model predicts that intelligent life could be unique to Earth, a sobering thought that amplifies our isolation. Imagine the implications. If Mars once harbored microbes, as Perseverance's findings hint, organic rings in hematite veins suggesting metabolic processes, 3.8 billion years ago, it would mean life emerges readily. But the path to sentience is fraught with filters, cosmic bottlenecks that snuff out potential before it blooms. Contrast this with optimistic voices, like those in a Guardian piece from March 2025, where leading space scientists argue that, assuming we're alone, reeks of human conceit. Life, they contend, must extend beyond Earth. Given the sheer scale of the observable universe, 2 trillion galaxies, each brimming with possibilities. The discovery of extremophiles on our own planet bolsters this view. Microbes thriving in Ethiopia's scalding hydrothermal vents, or Antarctica's subglacial lakes, demonstrate life's tenacity in extremes that mirror ancient Mars. If Jezero crater's clays preserve nitrogen and carbon from a watery past, as Perseverance's pixel scans indicate, it suggests that wherever liquid water persists, biology might follow. Yet, the Fermi paradox lingers like a shadow. Why no radio signals, no megastructures dimming distant stars, no probes zipping through our system? A phys.org article from April 2025 highlights recent detections of promising exoplanets, raising hopes that we're on the cusp of contact. But the great silence persists, fueling theories from self-destruction to zoo hypotheses. Perhaps advanced aliens observe us like animals in a preserve. Enter the dark forest hypothesis, a chilling resolution popularized in Liu Cixin's science fiction, but grounded in game theory. The universe is a dark wood where civilizations hide, fearing predatory others. A February 2025 piece from Union Rayo posits that life is common but silent, each society cloaked to avoid annihilation. This resonates on X, where users like @Neptune.1 discuss it in threads from September 17, 2025, linking it to the SETI Institute's ongoing failures, no detections despite decades of listening. If 3I/Atlas, with its cyanide-laced tail and iron-deficient core, carries exotic organics from a distant star, it could be a benign messenger or, in this forest, a unwitting beacon, drawing unseen eyes. Avi Loeb's speculations amplify this. What if the comet's anomalies, like its extreme negative polarization observed by Hubble, hint at artificial origins, a probe scouting habitable worlds like early Mars? The flyby might then represent not isolation, but a subtle interaction, a cosmic whisper challenging our solitude. The terror of being alone is twofold. As articulated in a Space.com exploration from April 2025, if we're the universe's only sentience, the responsibility weighs heavy. Extinction here means the cosmos falls silent forever. Perseverance embodies this burden, its name a nod to the dogged human spirit, probing Mars's regolith for traces of kin. Recent isotopic data from Jezeros's delta, detailed in Nature 2025, show carbon fractionation patterns akin to Earth's microbial processes, suggesting life once pulsed there before the planet's magnetic field collapsed 3.7 billion years ago. If confirmed via sample return in the 2030s, it would imply life is resilient but fragile, vulnerable to planetary whims. Yet, the alternative not alone bruises egos. As a Quora thread from October 2024 notes, "We're not the pinnacle, perhaps mere novices in a galactic community." Religious and philosophical traditions grapple with this. Some see it as divine affirmation, others a humbling demotion. Panspermia adds intrigue. Life seeds hitchhiking on comets like 3I/Atlas, dispersing across systems. Spherex's August 2025 detections of water, ice, and CO2 fog in the comet's coma suggest it could ferry prebiotics, mirroring deliveries that might have kick-started Mars's lakes. If extremophiles, those hardy Earthlings surviving radiation doses lethal to us parallel Martian fossils, it supports a connected cosmos, where life migrates but intelligence evolves sporadically. A Reddit discussion from May 2024 echoes this. Vast distances and timescales isolate us. Even if aliens abound, light years become barriers, turning potential neighbors into ghosts. On X, Adhagawi ties it to great filters in September 2025 posts, pondering if civilizations self-destruct before interstellar leaps. As we teeter on climate and AI precipices, perseverance as a virtue shines here. The rover's autonav dodging dunes, its moxie brewing oxygen from thin air, symbolize our refusal to accept silence. Producing 122 grams of breathable gas by 2023, it previews human tenacity on Mars, where we might one day confront our aloneness by becoming multiplanetary. Yet, this dream underscores a stark truth. There's no planet B. Mars's desolation once habitable, now a freezer after losing its atmosphere, mirrors Earth's fragility. X-user at LowWW Self-Esteem links it to mass extinctions in September 2025, noting how prior events lacked human traces, fueling Fermi debates on why no ancient ruins litter the stars. Exploration isn't escape. It's stewardship, urging us to heal our world while reaching out. The flyby bridges these realms. 3I/Atlas, a galactic drifter, might carry life's echoes. Its retrograde orbit a curveball in Fermi calculations. If orbiters detect biosignals in its tail, polycyclic aromatics, or chiral molecules, it could affirm life's ubiquity, shifting the paradox toward hidden societies or temporal mismatches. A Planetary Society article from May 2025 delves into this. Intelligent life might abound, but we're early arrivals, or they're post-biological, merged with machines beyond detection. X discussions, like at Science Fandom's thread on evolutionary diversity, speculate on alien intelligences, perhaps silicon-based or hive minds that evade our SETI net. Treat-li-vu true invites introspection. Being alone imposes duty. Preserve this miracle, lest the stars echo empty. Not alone invites humility, perhaps cooperation or conflict. As at Zen-style quips on X, advanced civs might expand inward. Virtual realms solving Fermi by retreating from the physical. Mars, with its extremophile analogues, and comets like Atlas, with panspermia potential, blur lines, suggesting life as a cosmic constant, intelligence the rarity. In this dance of doubt and discovery, perseverance defines us not just the rover, but our species' quest. No Planet B reminds, cherish Earth, explore wisely, As 3I/Atlas nears, it connects Mars's whispers to galactic shouts, urging, "Look up, wonder, and ponder our solitude or company in the grand expanse." As the cosmic clock ticks toward October 3rd, 2025, the interstellar comet 3I/Atlas streaks closer to its rendezvous with Mars, a fleeting brush that promises to reshape our understanding of the universe's wanderers and leave an indelible mark on humanity's exploratory saga. This isn't merely a celestial sideshow. It's a pivotal moment where data harvested from orbiters and telescopes could unravel the comet's enigmatic composition, potentially revealing pristine materials from a stellar cradle billions of years distant. Imagine the Mars Reconnaissance Orbiter's high-resolution cameras locking onto the comet's nucleus during that 30 million kilometer pass, capturing details finer than Hubble's gaze. Jets erupting from its icy core, or subtle asymmetries hinting at untold formation stories. Europe's ExoMars Trace Gas Orbiter, with its sensitive spectrometers, might sniff out volatile molecules evaporating in the coma, confirming the water ice and carbon dioxide fog detected by SphereX in August. And what of NASA's Parker Solar Probe, swinging through the inner solar system? Recent projections suggest it could observe 3I/Atlas from late September into early November. Its wide-field imager for Solar Probe, peering through the comet's dusty veil as it hurtles sunward. These observations aren't passive. They're a treasure trove waiting to be mined, with potential to challenge models of interstellar object frequency estimates now whisper that such visitors might pass through our system annually. Yet, we've only spotted 3 post-flyby. The data deluge will cascade back to Earth, fueling analyses that could upend astrophysics. By mid-October, as the comet nears perihelion on the 30th, at 1.4 astronomical units from the Sun, its brightness might spike, turning it into a naked-eye spectacle from our planet. But the real revelations lie in the spectra. The sudden green hue shift, captured in fresh images by astrophotographers Michael Yeager and Gerald Riemann just days ago, evokes questions about dicarbon dissociation or exotic chemistry. Could this verdant glow signal processes unseen in solar system comets, perhaps forged around a metal-poor star in the galaxy's thick disk? If cyanide and nickel abundances exceed expectations, as hinted in preliminary Hubble data, it might bolster panspermia theories, suggesting these nomads ferry life's precursors across voids. Scientists at the SETI Institute are already buzzing. What if isotopic ratios match those in Jezero crater's organics, linking galactic drifters to Mars's ancient lakes? The comet's extreme negative polarization, a dust-scattering quirk defying norms, adds another layer, natural fluffiness, or something engineered. Avi Loeb's latest musings, shared in a recent interview, speculate that anomalies like the anti-tail could indicate artificial origins, though mainstream voices counter with explanations rooted in radiation pressure. This tension will simmer as teams pore over the haul, potentially rewriting textbooks on how interstellar objects survive eons of cosmic bombardment. As 3I/Atlas slingshots outward after perihelion, grazing Venus in November and feeling Jupiter's gravitational tug by March 2026, its trajectory becomes a roadmap for future pursuits. The comet won't linger. Its hyperbolic orbit ensures a swift exit from our system, vanishing into the Milky Way's depths. But the questions it leaves behind will propel missions like ESA's Comet Interceptor, poised at the Sun-Earth L2 point from 2029 onward. This spacecraft trio, armed with dust analyzers and plasma sensors, awaits a similar interloper, ready for a high-speed intercept to sample ices untouched by solar heat. Redwire's onboard tech, delivered earlier this year, promises agile responses. But imagine the thrill if it targets an Atlas-like visitor. Close flybys dissecting comas for biomolecules, perhaps chiral compounds hinting at life's handedness beyond our cradle. These endeavours build on Perseverance's legacy, where the rovers cached samples 43 tubes by now, brimming with delta muds and veined rocks, await retrieval in the Mars sample return mission. Funding hurdles notwithstanding, Lockheed Martin's streamlined proposal could accelerate this to the late 2020s, with a European fetch rover scampering across Jezero to collect those breadcrumbs, loading them onto a rocket that blasts off Mars for the first time in history. The design of this era extends far beyond hardware. It's a catalyst for inspiring generations, igniting sparks in young minds who gaze at the night sky and dream of footsteps on rust-red soil. Perseverance, with its name evoking unyielding resolve, has already transformed public perception. Viral videos of its 7 minutes of terror descent in 2021, or Ingenuity's defiant flights defying Mars's thin air, have captivated billions, turning abstract science into relatable triumphs. Schools worldwide incorporate rover data into curricula students, simulating Jezero's geology, or debating biosignatures in Chayava Falls, where organic rings suggest microbial feasts on iron eons ago. This inspiration fuels a pipeline of innovators, from Kenyan researchers like Gerald Leperio sharing Comet updates on X, bridging local curiosity to global missions, to amateur astronomers processing Hubble images of 3I/Atlas's teardrop coma, democratizing discovery. The comet's green transformation, as if nature's own alchemy, stirs artistic imaginations, poets and filmmakers weaving tales of interstellar messengers, while educators use it to teach orbital mechanics or chemical spectroscopy. What untapped potential lies in a child today, inspired by this flyby, who might one day helm a human mission to Mars? Human exploration of the red planet looms as the ultimate horizon. A DSAN Perseverance paves with every wheel track. The rover's MOXIE experiment, having brewed 122 grams of oxygen from Martian air, proves in situ resource utilization, a blueprint for astronauts to generate breathable gas and propellant on site, slashing the tyranny of launch masses. MEDA's weather logs, chronicling dust devils and radiation fluxes, inform habitat designs. Shielded domes against cosmic rays, perhaps burrowed into regolith mapped by RIMFAX's subsurface radar. NASA's Artemis program, evolving in 2025, eyes Mars as the next leap. Lunar outposts testing tech for the 2030s crewed voyages. SpaceX's Starship prototypes, iterating rapidly, promise reusable transports ferrying humans to build bases near Jezero, where they could analyze Perseverance's samples in makeshift labs. But the intrigue deepens. What psychological tolls await isolation in a hostile world echoing our cosmic solitude? Or, if 3I/Atlas's data hints at panspermia organics matching Martian hints, might we find kinship in the stars, easing that loneliness? This journey from discovery to legacy circles back to the flyby, a nexus where past missions converge with future dreams. As 3I/Atlas departs, its path through Venus and Jupiter offers slingshot opportunities for opportunistic probes. Perhaps a CubeSat swarm launched from Earth's orbit, chasing its tail for direct samples. The comet's composition, iron-poor yet nickel-rich, could illuminate galactic evolution. Born in a population 2 stars nebula, it carries isotopic scars of supernovae, potentially matching anomalies in Mars's xenon, suggesting shared catastrophic histories. If Parker Solar Probe's observations confirm volatile bursts near perihelion, it might explain the green shift dicarbon glowing under solar assault, or reveal hidden reservoirs of ammonia, prebiotic gold. These insights ripple, enhancing models for Comet Interceptor, informing defenses against near-Earth threats, or even guiding bioengineering for Mars habitats, where extremophiles adapted from Earth could terraform soils. Yet, the true dessin lies in the intangible, the spark of curiosity that propels us forward. Perseverance's endurance, outlasting dust storms that felled predecessors, mirrors our species' grit. From Viking's ambiguous life hunts in 1976 to Curiosity's habitability proofs in 2012, each step builds resilience. 3I/Atlas, the third interstellar beacon after Oumuamua and Borisov, reminds us the galaxy is alive with motion, perhaps teeming with untold stories. Amateur contributions, like those processing September 17th images showing the comet's evolving brightness, underscore this. Science as a collective endeavor, where backyard telescopes complement billion-dollar orbiters. As the comet fades, its legacy endures in classrooms, inspiring coders to simulate trajectories or biologists to study panspermia's viability. Looking ahead, the 2030s beckon with human boots on Mars, crews drilling deeper than rovers, perhaps unearthing unambiguous fossils that rewrite biology. NASA's plans for sustained presence, fueled by MOXIE-scale plants producing tons of oxygen, envision outposts harvesting water ice mapped by rimfax, sustaining gardens under domed skies. SpaceX's visions amplify this. Fleets of starships ferrying colonists, turning science fiction into fact. But curiosity tempers optimism. What ethical dilemmas arise if we find dormant life? Quarantine protocols for sample return already evoke caution, ensuring no back contamination taints Earth. And if 3I/Atlas's flyby yields no anomalies, reinforcing its natural pedigree, it still enriches our narrative proof that the universe's drifters are common, perhaps seeding worlds like early Mars with the stuff of life. Embrace the night sky, then, as a canvas of possibilities. On October 3rd, as orbiters beam back images of the comet's Martian silhouette, let it stir your imagination. A wanderer from the void, brushing our neighbor, carrying echoes of distant suns. This moment, blending Perseverance's ground quest with celestial serendipity, encapsulates our drive to explore, to question, to connect. The legacy isn't in answers found, but in mysteries pursued, generations inspired to reach beyond. As 3I/Atlas vanishes into the galactic night, it leaves us pondering, what other travelers await, and what tales will they tell? The universe, vast and veiled, invites us to keep watching, wondering and wandering onward. If this cosmic adventure resonates with you, why not hit subscribe and enable those alerts to join in on future discoveries?